Welcome to Objective 6. So we are halfway through now all of the modules. So this next module is looking at coordinate systems and looking at different norths and how to calculate between them and everything along those lines. So this is usually the module where people get really hung up on. And so I'm going to do my best to try to take it slow with you guys, doing one objective at a time in each video so that you can keep going back to it. I will be using my little online whiteboard here for a lot of it as well. So we'll work through it. Don't get too overwhelmed. You're going to see some examples. There's going to be the discussion thread. There's going to be a lot of working through this. So some of it you may have seen before, some of it you may have never seen. So we'll just hop right into this. So we are going to be looking at terms such as latitude, longitude, above mean sea level. What do those mean? We're also going to be looking at those coordinate systems. Now, really, when you talk to anybody, geomatics people are like the coordinate system people. So if you're a professional, you're working in the industry, they're going to expect you to know coordinate systems and how they apply and how to implement them and how to calculate between them and so forth, right? So this is really an introduction to that. The stuff that I'm covering here is like the backbone to your geodesy class and moving up into geodesy and map projections. So the objective 6.1 is looking at Cartesian, polar, and geographic coordinate systems. So you should be familiar with Cartesian coordinate systems. That is the XY coordinate system or the XYZ coordinate system, depending on whether you are in 2D or 3D. It is also known as a rectangular coordinate system. Then we can take that Cartesian and convert it into polar. Now, what polar is radius and angle. If we do it in 3D, it's known as spherical coordinate system, so we can kind of convert between the two of those, depending on 2D or 3D. So this is with a polar coordinate system. This is what you're doing in the field, right? So you set it once you are starting to use a total station, you set a 0 and you turn an angle, and you calculate what that angle is, and then you calculate a distance, and then you figure out what your coordinate is of that to that point, to what you calculated or observed that distance to. So that is what you're observing, and then we put it into a Cartesian coordinate system to get that x, y, and z value. So you're always working in between these two in surveying. Now, when we deal with Cartesian well, not so much Cartesian, but polar specifically, when we're dealing with polar, we read in geomatics, we actually read the angle from the y-axis. And there are a few exceptions to the rule. There's always an exception, but for the most part, especially in mapping or remote sensing, everything we read is from the y-axis, and we read it in a clockwise direction. So that is really important for you to remember, that we're not looking from the horizontal, which is what you're used to. You're used to seeing everything from the horizontal, but now we're reading it from the y. And I also want to point out that y is not always north. And that is, we often have north pointing up, but sometimes north is pointing towards you. Sometimes north is pointing to the side. It all depends on the coordinate system that you are working with. So don't assume that y is north, because it may not be. Z might be north. X might be north. It just depends on the coordinate system. So when we're using polar coordinate systems, we have our radius and angle, or sometimes it's written as angle and radius. It is not written as the Cartesian coordinates. Then we have geographic coordinate systems, which is another set of coordinate systems. Now, geographic and geodetic are two that are very similar. The difference between geographic and geographic is based on a sphere. Geodetic is based on an ellipse, or ellipsoid, sorry. These are called curvilinear coordinate systems because their axes are based around circles or ellipses. So you're not going to have a straight line. So geographic coordinate systems, curvilinear coordinate system that's based on a sphere. Geodetic coordinate system is a curvilinear coordinate system that's based on an ellipsoid. So we look at geographic coordinate systems as latitude and longitude. There is a video that in the state library that I'm going to provide a link to that I'd like you guys to look up and watch. It's a very good introduction into latitude and longitude. So I do suggest watching it. And so the latitude, this is where people get really confused because latitude is your y direction and longitude is actually the x. And you'll see that in the video, and it's just because as you move around the x direction, it's actually your longitude that is changing. As you move north-south, if you move along one of the longitude lines, it's actually the latitude value that's changing, not the longitude. So that is why the x and y, if you want to call them, y is known as the northings and x is known as the eastings. And so that is what those kind of break up into. And a lot of people have those mixed up in their heads because the longitude lines run vertically, but they don't change along that vertical line. So try to wrap your head around that one. So the other thing with latitude is that as you move away from the equator, those circles get smaller and smaller. With longitude, as you move away from the zero, they all stay the same. So they're always going to stay the same size. Longitude is always, always, always the same size. Latitude, you have a distance, or the distance around the circle changes. So here's some visual pictures of them. So we have the Cartesian coordinate system, which has points. So if you have one kind of in space here, you have a z value going up the z-axis. You have the y value, which comes along the y, and you have the x, which also comes along there, and you get a three-dimensional point. In polar coordinate systems, we measure off of the axis pointing up, so the y-axis in this case, and we have the radius to identify where point P is, and point P is known as theta r, and theta is the angle. Geographic, we have our latitude, which is the circles that go around horizontally, and then we have the longitude, which are the values that go around vertically. And you can write them as latitude, longitude values, or you can write them as longitude, latitude values. You will see both, and it depends on the system, the software that you're dealing with. So latitude and longitude, they run, so longitude, like I said, runs vertically around the Earth, passing through the poles. It's a little bit more detail there. They're all the same size. They also have a fancy name called great circles. So with that, the great circles means that you can't get any bigger than those circles that they create when you look at them. Or you slice the Earth in half, that's what I mean. So it's a perfect half of the Earth. It's always going to cut it in half. 0 is at the line that runs through Greenwich in the UK. There was a big debate about that, and the UK won because they had more explorers or something that were coming out of there, and so that's why they used it. The values go to 180 degrees. Even though there's 360 degrees all the way around the circle, there is, but how we measure it on the Earth is we start at 0 in Greenwich and we go either east or west. So then you go wrap all the way around, and then you have the line of 180 degrees on the other side of the Earth. And that one we just represent as east or west. And if you go west with lines of longitude, west can be represented as a negative rather than putting a W. So if you're looking at just numerical values in a software, you can represent west with a negative. Latitude lines, they run horizontally around the Earth. Like I said, they're different sizes as you move away from the equator towards the pole. And 0 is at the equator. And the equator is the only great circle. The rest of them are smaller. They don't actually cut the Earth in half. So the values for latitude go up to 90 degrees instead of going 180. So because it's really just a straight line up and down, even though it's curved. But we represent each value as north or south. And if we are going to use just a numerical value, south is represented as a negative. So again, there is a video that I have listed that I would like you guys to watch on this. We are not going to be doing any mathematics with this at this time because it's all curvilinear calculations, and it's based on arcs. So I'm not going to push you through that at this time. You'll get to learn that in Geodesy. So that kind of summarizes very briefly the what these are, these different coordinate systems. And will be moving on to Objective 2 in the next video.